So in the previous video we had a think about wind in urban areas. This video we're going to focus in a little bit more detail. It's a slightly revisit of photochemical smog. You might want to pause this video to remind yourself about the information we've already looked at with smog, and I think there our focus was in particular winter smog. So hopefully you've paused that video and you've reminded yourself about the sort of meteorological weather circumstances we would get smog. So we would get that with high pressure, stable conditions, sinking air, blue skies, very little wind, so there's nothing to blow that pollution away. Also, it's going to be doubly worse in cities like Beijing, which are actually surrounded by hills on several sides. So it acts as a bowl and that pollution actually gets trapped in. So I want to give you a little bit more understanding of exactly what photochemical smog is. So in the previous video I talked a little bit about NOx, nitrogen oxides. It's not just that. They're as a result of transportation and industrial activity, as well as the nitrogen oxides, you'll also have all sorts of chemicals in there. A big range of chemicals called volatile organic compounds, or VOCs. They're volatile because they're quite complex molecules and they can be broken down. And that's the key thing that we would have here. So in the presence of strong sunlight, and as a also in the presence of in the presence of that sunlight, those chemical bonds start being broken down. And some of that will contain oxygen and free radical oxygen. So that oxygen starts whizzing around and will, under certain circumstances, will recombine to make ozone. Ozone at low levels is not good. It is actually toxic and highly detrimental to human and animal health. So we actually end up with quite a complex cocktail of chemicals, various forms of various NOx compounds, various new VOCs, low-level ozone. So in combination, the effects of that smog on human health and the environment can be very, very serious and harmful. It is one of the reasons why Hong Kong has those health warnings. And certainly many schools in Asia will actually stop outdoor physical activities when the pollution levels reach a certain level. Again, we understand the physics, we understand the science, so we've actually got quite good predictive models. So here in Hong Kong, with the Hong Kong Observatory, they actually send out predictions of when we're going to have high levels of pollution, and then schools and vulnerable people, they can take action before it becomes a problem. Certainly many schools in Asia, our school is an example of this, have pollution monitoring stations, so we know exactly the pollution levels in our particular location, and then we can change student activities once we've got that information. Quite often, sometimes you will actually see this when you come flying in, and you will see it actually as a yellow haze. You can actually see the pollution itself. Unfortunately, in cities like Hong Kong, you can actually taste and smell the pollution as well. But remember, if you are coming in or out of the airport and you see that yellow haze, you're not only seeing the pollution and all those volatile organic compounds and NOx's and ozone. You're not only seeing that, but also effectively you're seeing the urban heat island as well. So remember, we get this. We get the urban heat islands, and when you get surrounding geology, you get surrounding mountains, then basically that pollution is locked in. And here is an example of Beijing. It is a huge problem in Beijing because of the size of Beijing. It's one of the world's mega cities. Has a city with a lot of industry as well, and unfortunately, because of its geographical location, it is surrounded by hills. So we can see multiple factors interplaying with each other to actually make this a very severe problem. Winter smog, which we talked about before, that's slightly different. I think that's simpler to understand. So that's just, you get the smoke and it sits there for a long period of time and simply cannot move. Because of the colder conditions, you tend not to get photochemical smog because you haven't got enough energy, solar energy coming in to break those volatile organic compounds and break those NOx chains. So winter smog is very, very dangerous. I think I'd rather take my chances, if I would have to say, I'd want to take my chances with the winter smog rather than the photochemical smog. My feeling is that it would be a lot more toxic. Okay, so in this series of mini lectures, we've thought about problems, and all along I've been saying to you that these are well-known problems. We know the physics behind them, we know why these things happen, we can predict them, and also increasingly I've been saying we can manage them, we can modify our urban environments. So then what we're going to go on to do in the next unit of work is look at some case studies of us actually trying to restore those urban microclimates. And we're going to start off with an excellent case study from Seoul in South Korea.